In this presentation, we have to talk about Q value of a nuclear reaction, and also we have to derive an expression for Q value. The Q value of a nuclear reaction describes the amount of energy either released or absorbed during a nuclear reaction. If energy is released, the Q value is positive and the reaction is exothermic. If Q value is negative, the reaction is endothermic and the energy is absorbed. Q value may also be defined as the difference between the kinetic energies of the products and the incident projectile particle. Here is a nuclear reaction. X is the target at rest, A is the incoming particle. The daughter nucleus Y and an outgoing particle B are produced during this nuclear reaction. The entire reaction is provided in this form. Here, EA is the kinetic energy of the incoming particle. The target is at rest, therefore the kinetic energy of the target is 0. EY is the kinetic energy of the daughter nucleus, and EB is the kinetic energy of the outgoing particle. The response energy of the incoming particle is mAc square. The response energy of the target is mxc square. Then the response energy of the daughter is mic square, and the response energy of the outgoing particle is mbc square. We have given the response and other things here. Mx response of the target, small m suffix x response of the incoming particle, small m suffix b response of the outgoing particle, capital M suffix y response of the daughter. Because X is the target, small a is the incoming particle, Y is the daughter, and B is the outgoing particle. Now, Q value is equal to EY plus EB, is the kinetic energy of the products. EY is the daughter, that means kinetic energy of the daughter. EB is the kinetic energy of the outgoing particle. EA is the kinetic energy of the incoming particle. Now read out this definition. Q value is the difference between the kinetic energies of the products and the incident projectile particle. See this. Now, according to conservation of energy, according to conservation of energy, the kinetic energy of the incident particle plus response energy plus the response of the target, which is equal to kinetic energy of the daughter EY plus response of the target, response of the daughter myc square plus kinetic energy of the outgoing particle EB plus response energy of the B. MB C square. These two corresponding to incoming particle projectile. This is the response of the target. These two corresponding to daughter. These two terms corresponding to outgoing particle. Now, according to the definition, Q equal to EB plus EY. This is EY plus EB. EY plus EB minus EA, which is equal to, see here, EY plus EB. Then shift the rest of the terms to this side. Then minus EA, which is equal to MA C square plus mx c square minus my c square plus mb c square. This is equal to mx plus ma minus my plus mb entire is multiplied by c square. This is q equal to ey plus eb minus ea. This is equation 1. Now we have to find out the value of ey. For that, consider this diagram. X is the target. The incoming particle A is moving along the x direction with a momentum MAVA. Once the reaction is taken place, the outgoing daughter makes an angle pi with the initial direction, and the outgoing particle B makes an angle theta with the initial direction. Now we have to separate the momentum into two components. One is x component of momentum and another one is y component of momentum. The x component momentum of the daughter is my by cos pi, whereas the x component momentum of the outgoing particle is mb vb cos theta. Here b is the outgoing particle which makes an angle theta with the initial direction. If you think about the y component of momentum, the y component of momentum of the daughter is my vy sin pi, whereas the y component of momentum of the outgoing particle is mb vb sin theta, because b makes an angle theta with the initial direction. Now, using the conservation of momentum, we have derived the value of ey. According to conservation of momentum, MAVA, which is equal to, see here, the momentum of the incoming particle is MAVA plus momentum of the target. Target is at rest. The momentum of the target is 0, which is equal to sum of these two momenta. That means x component momentum of the daughter and the x component momentum of the outgoing particle. Now you have to take the sum. My by cos pi plus mb vb cos theta. This is x component momentum. Keep this equation 2. Now study the y component momentum. Here the incoming particle is moving along the x direction alone. It's not moving in the y direction. So the y component of momentum of the incoming particle before the reaction is 0. Already the target is at rest. So before the nuclear reaction, the momentum factor is 0. Once the nuclear reaction is finished, we may concentrate the y component momentum of the daughter and the outgoing particle. Here the daughter is making its recoiling motion, so that the momentum of the daughter is opposite to that of the momentum of the outgoing particle. Now we can write my Vy sin pi, which is equal to mb Vb sin theta. This is y component of momentum. Actually, we have to write the initial momentum along the y direction of the incoming particle is 0 plus initial momentum of the target 0 along the y direction, which is equal to my Vy sin pi with a negative sign plus mb Vb sin theta. Therefore, mb Vy sin pi equal to mb Vb sin theta. This is the y component of momentum. This is equation 3. Now modify equation 2. My Vy cos pi, which is equal to, keep this term, then ma Va minus mb Vb cos theta. This is equation 4. Just we have modified equation 2. From 2 we have written this equation 4. Now make the square of 3 and 4, then add 3 square plus 4 square gives my square Vy square sin square pi plus my square Vy square cos square pi. Left hand side, then right hand side square mb square Vb square sin square theta plus, make the square of these two terms, ma square Va square plus mb square Vb square cos square theta minus 2 times ma mb Va Vb cos theta. This we have used a minus b whole square formula. Then take this my square Vy square outside. We can write sin square pi plus cos square pi, that is equal to 1. So the left hand side is my square Vy square, which is equal to, combine this mb square Vb square and this term mb square Vb square sin square theta plus mb square Vb square cos square theta is equal to mb square Vb square. Because if you take out mb square Vb square outside, then we can get sin square theta plus cos square theta inside the bracket, that is equal to 1 plus this term ma square Va square minus 2 ma mb Va Vb cos theta. So this is equation number 5. You know that Ea equal to half ma Va square. Then Eb equal to half mb Vb square. Then Ey, kinetic energy of the daughter, equal to half capital M suffix y Vy square. Then from this Va square, which is equal to 2Ea by ma, then Vb square is equal to 2Eb by mb, 2Eb by mb. Then Vy square is equal to 2Ey divided by my. Now we have to substitute all these values in equation 5. Now phi becomes my square, then Vy square is this much, 2 into Ey by My, which is equal to Mb square. Vb square is 2 into Eb by Mb plus Ma square into Va square. Va square is 2 into A by Ma, then minus 2 Ma Mb. Va means root of 2 Ea by Ma inside the root into Vb, 2 Eb by Mb inside the root. Entire is multiplied by cos theta. Now we have to simplify this. This is 2 Ey My, which is equal to 2 Eb Mb plus 2 A Ma, which is equal to here root 2 into root 2, 2 into 2, 4. Here Ma and Mb are outside the root, here Ma and Mb are inside the root. Therefore, this is Ma, Mb, Ea, Eb inside the root. Entire is multiplied by cos theta. Now put some number for this. This is equation number 6. Now the value of Ey equal to Eb by My. We need Ey alone. We have to divide all the terms by 2 My. Say My into Mb plus Ea by My into Ma. Then minus 2 divided by My into Ma, Mb, Ea, Eb cos theta. This is equation 7. Now we have to substitute this in equation 1. You know that Q equal to Ey plus Eb minus E suffix E. Now Q equal to Mb by My into Eb plus Ma by My into Ea minus 2 divided by M capital Y into Ma, Mb, Ea, Eb into cos theta. This is the value of Ey plus Eb minus Ea. Now we have to simplify this. This is equal to Eb into Mb by My plus 1. Just to combine these two terms. Plus take out A outside. A into Ma by Mi minus 1. Then minus 2 divided by my, ma, mb, ea, eb. See here also we have to put power 1 by 2 because root is present. Here we have to put 1 by 2. 1 by 2 cos theta. Because all the terms are present inside the root. 1 by 2 into cos theta. This is the value of Q. Now, if you consider the daughter nucleus and the outgoing particles are coming out of the normal direction to the incident particle, the value of theta is pi by 2. If theta equal to pi by 2, both the daughter nucleus and the outgoing particle are coming in the perpendicular direction to the incident particle, this term is vanished. If theta is pi by 2, cos pi by 2 is 0. Now the Q value becomes Q equal to EB into MB plus MY plus 1 plus A into MA divided by MY minus 1. The last term is discarded. So in this level we may write the Q value of nuclear reaction. Here EB is the kinetic energy of the outgoing particle, EA is the kinetic energy of the incoming particle, MB is the response of the outgoing particle, MI is the response of the daughter nucleus. If you substitute all these values, you can get the Q value of the nuclear reaction.